I first want to thank Terrell for giving me the opportunity to present some of the Delft teaching on quantum, and I also want to connect to one remark that he made. Please wait until the end, because these professors usually do not know about all these practical details, and indeed I am among that species. And on my last sheet I will give you the coordinates of the person who will certainly not mind if you contact him, and who knows really everything. So let's look at quantum. I have divided up my presentation into no less than 5 parts. I first want to introduce you to the Netherlands, and in particular quantum in the Netherlands. Then an institute, an important institute these days in quantum technology, which is called QuTech, which is related to the university, but it's not in the university. I want to briefly present a minor program on quantum technology, and then a quantum track, so it's encapsulated in the so-called Master Applied Physics, of which I am the director. And then I want to conclude with some more general remarks of where quantum is heading to.
Do you want to share your slides also?
Oh yes, yep. Sorry, I forgot to do that. Then I should share this screen. Yeah. So let me then perhaps flash back to the previous one. Here you can see indeed what I just said. That's the program of the outline of my talk. So in the Netherlands we had a big flood in 1953, and it flooded the country, and so people started then building an enormous system of gigantic dikes and bridges and all that kind of stuff. You see that in the lower right, and those are known as the Delta Works. And whenever in the Netherlands there is a big nationwide project, they call it a Delta Plan or a Delta Works, in analogy with that endeavor. And so now we have the main players in the quantum technology have gathered into the so-called Quantum Delta Netherlands, and they have produced a startup document, the Quantum Agenda. So quantum is something which is really alive and vibrant in the Netherlands. So here you see a few of the things that they are planning and what they are working on. Look at the right. So there is a catalyst program on quantum computing and simulation, national quantum network. So people are already making plans of connecting the entire country using a quantum internet, and there are quantum sensing applications. And a very important player in the field is QuTech, which is a Quantum Technology Institute, and it has several divisions. And what they want to do is they want to have demonstrations of several types of quantum computing. So one of the main things they are doing is topological quantum computing with Majorana fermions, but they also have quantum internet, generally quantum computing with also with superconducting networks. And what they do on the field of teaching is somehow gathered into what they call the QuTech Academy. Most of the people from QuTech, whom I know at least, they have also a joint position at the TU Delft. I mean, it started really at the Technical University Delft, Delft University of Technology, and it split off somehow, and now it's a mission-driven research institute. And here you can see, if you want to have an impression of the of what they do and on quantum technology, it may be nice to look into the edX courses which they present. And here you see a few of those, and they are probably easy to find if you log on to the edX website and then try to find these titles. There are also ideas of a quantum campus. So there is the Technical University, there is QuTech, and there are many spin-off companies. Microsoft and Intel invest a lot into this QuTech, and so The ideas are that we are developing a quantum campus in Delft, and in 2025 it's expected that between 20 and 30 companies would be on that campus, on the quantum campus. Now, what do we offer in Delft programs? Well, I am mainly focusing on the first one, that's in the Faculty of Applied Sciences. There we have applied physics, and it has different tracks. But you can have a strong quantum program, a strong quantum profile within the Applied Physics Master Program. Then there is a Faculty of Electrical Engineering, Math and Computer Science, and in the field of quantum we collaborate a lot with them. However, in their master programs there is some quantum possible, but it's not to be compared with what we offer in the Applied Physics. Well, first we have a program. It's perhaps not for everybody in the audience that interesting, but perhaps some people may think, hey, that's something for me. We have a program, a minor program on quantum science and technology. It's also open for international students, and it's 30 EC of quantum technology, which is on the bachelor level. We have started last year with 34 students, and this year we have 60, well, I think it's 61 students are currently in that program. And it's what is interesting is that it's a program which is accessible not only to applied physics students, but also for applied mathematics, computer science, electrical engineering. So it's rather open. This is what the program looks like. So it's one semester. You see it starts in September, December, and then there is 1 month in January. 4 parts, and in the beginning that's an introductory part, and there we distinguish for the people from applied physics. They don't need to they don't need to learn new quantum physics, but they get information and computation because that's where they are weak at. And the other students get quantum physics. And then you see they also get some math. It's more or less a refresher so that everybody is on the same page. And then there is semiconductor quantum bits, superconducting quantum bits, quantum communication and computation, quantum sensing and measurement, so all the important ingredients of quantum computation and quantum communication. And then they do a group project in January, and that is on some quantum simulator or on a real quantum computer. Then the Master of Applied Physics, that's 120 ECTS. ECTS are European credits, and 120 ECTS is just 2 years. It's a program of 2 years. And the tuition fee, that may be interesting for American students because it's ridiculously cheap. I've understood for American proportions, it's a bit over 2,000 euros per year. 65 of the influx comes from our own bachelor program. We have 29 international students, and that's 50-50 divided between EU and non-EU. And it's possible to get scholarships. These scholarships are either from the Technical University of Delft, or QuTech also gives scholarships for the best students. So each year we have to select the best students for the scholarships. Now, what does our program look like? Well, this is it. It's a program which contains a substantial master and project. That's 48 EC, so that's nearly a year doing research in a group. And often there is even a paper coming out of that research, or sometimes even 2 papers. And the rest is math. We have 9 EC of math. It's math really above the bachelor level generally. We have ethics, in which we discuss, say, the societal implications of science. And there is a G list. The G list, I will come back to that. That's general physics. So we think that you should really learn more quantum and more statistical physics beyond the bachelor. And then the rest is all electives. I will not go too much into the details because you can find that on our web pages. And then we also have an orientation. Well, what is the orientation? Well, the orientation, there are 4 of those. But before I go into those, in this main program, in the core program, so that's everything except from the orientation, we have 5 tracks: physics for energy, physics for fluids engineering, physics for health and life, physics for instrumentation, but the most important, of course, in this context is physics for quantum devices and quantum computing. So, what are these orientations? So that was this blue part here, which is not in the, so the rest is the core program, and we have 1 semester orientation. Well, most students take research and development. That's a 3 months industrial internship or a design project and some electives. People wanting to become a teacher, do education, management of technology is possible if you want to become a boss in industry. And there is a Casimir, sorry, that was a misspell. There is a Casimir pre-PhD program for students interested in pursuing a PhD after the master. The G-list, general courses, well, those are the usual suspects: advanced electrodynamics, advanced quantum mechanics, advanced statistical mechanics, and we even have continuum physics, because we also have physics for fluid flow. And then the math, that consists of 3 parts: complex analysis, partial differential equations, and finite elements. So that every student in the master program has to go through this. They choose, however, 2 out of these 4 G-list courses. So you don't have to take all of them, you just choose 2 of those. And this is how the students run through the program. The first semester is the hardest one, because then they do all the math and they do the general physics courses. So they do, for example, statistical mechanics and electrodynamics. And I'm teaching the statistical physics course, and I can tell you it's hard. They have room for 1 tracklist course, and there is also ethics. And then in the second semester, they just take all the courses that they like. We have a list of over 60 electives, and students choose from those electives, and they already prepare themselves to the final project. So they search for a supervisor and they do the introductory reading. Usually they then start the second year with the final project, and then if they need to do an internship, if they have the research and development orientation, they do the internship in a company in the Netherlands or abroad. Now, what about quantum? This is our list of quantum courses, and I have highlighted in gray the quantum information and modern quantum technology courses. So there is those have a contribution from QuTech. So QuTech, indeed, this institute where they develop the quantum computing, they do these courses. So for example, fundamentals of quantum information, also with the project. There is quantum hardware, theoretical concepts, quantum hardware 2, that's the experimental state of the art, etc., etc. Quantum communication and cryptography, and also electronics for quantum computing. Of course, it's a highly multidisciplinary subject, so people need to be good at electronics, they need to be good at physics, they need to be good at programming. So it's all very much interdisciplinary, multidisciplinary. Well, these are the course description of those courses which were just highlighted. You can probably not read those, certainly not in the time that I allow you to look at this, but this presentation will be posted. So I trust that you will find the time later on to go through all these course descriptions. Now, if you are a real quantum nerd, there is a lot that the program can offer. There is a maximum amount of courses on quantum information science and technology. So that's really the modern quantum technology, quantum computing, and that's 32 EC. Well, what is an EC? I already said that that's a European credit. 60 EC is 1 year, so you have more than half a year of coursework. But then you can top that up with a choice of over 45 credits on other quantum subjects. So that's quantum theory, there's quantum applications of quantum, there's nanotechnology. You can do a final project in quantum mechanics, that's 48 EC. And recall that the core program has 90 EC in total, so you can easily fill it up with quantum. You can also, even if you are going on an internship, you may do that in a quantum company, and all your electives can be on quantum. The only non-quantum stuff that you need to do is math, 9 EC of math and 3 EC of ethics, and then you have one course on electrodynamics or on statistical mechanics. Well, statistical mechanics is also relevant for quantum technology. So in fact, there is very little which is non-quantum if you are the real quantum nerd. Now, what will quantum be heading for? Of course, it's always difficult. I mean, probably you guys have different backgrounds. There may be physicists, there may be people from electronic engineering, there may be computer science people. And so people come in with very different backgrounds, and also there are many different areas in quantum information in the modern quantum technology that we have. There is quantum computing, there is quantum communication, there is quantum sensing, but there is of course also still the quantum nanotechnology, quantum transport, etc. You can all do that in this program, and somehow every student has to find his or her match between the background and what the program can offer. Now, it is a physics program, so you really need to have a basis in physics. So even if you are from a different program, you either need to bridge that using other courses, but in principle, our intake are physics students, physics or applied physics. Well, here is my 5-cent opinion about on the development of the new quantum technology. Well, we all know what happened to the computers. In the 60s, people were sitting in big rooms with these big computers, and they were really experts, and they were the only ones who could operate the machines. Now, this is what we see today. Everyone has a computer and everyone can play around with that. And that happened in a period of about 50 to 60 years. That we went from the left picture to the right picture. And that is ordinary computing. And that's why I called it the old information revolution. But now we have the quantum information revolution. And now we are in the stage where the experts are operating these high-tech devices. And we don't know what the future will be. And in fact, I Googled future of quantum computing and I got this picture. And well, if you can make any sense out of it, be my guest. But I think we don't know what the future will bring us. The only thing I can get from these pictures is that the future will be very blue. But I think it's an exciting time. We do not know where it all will end, but it will probably be a revolution which also changes, which will also change our lives just like the computer did. Now, this is the most important sheet, I guess, for most of you. This is my name, Jos Thijssen, and my email address, but this is the guy who knows everything. So this is the program coordinator, Arno Hackett, and he knows everything about admissions. You can also find information on these websites, and here is the international office. They also can give you details for admissions of international students, but preferably the first place to go to is Arno Hackett. But please also check out the university international intake places, admission places, because they will tell you what the conditions are. I think generally the GPA should be 75%, but it's not for every university. And we look at every student individually and then we decide on the admission, but you should first be admitted into that process. And that then you need to meet some general requirements imposed by our university. And then from the QuTech side, so I mentioned already the QuTech Academy. They have a set of courses which are also part of our program, and also they have ethics courses. And you can contact them under info QuTech Academy at tudelft.nl. So I guess that's what I wanted to say, and if there are any questions, I will be very happy to answer them.
Thank you, Jos. That's, boy, I get the impression your program is not for the faint of heart. I get a little, it's quite a highlight when a professor for one of the first year courses kind of gives you a warning that it's not easy. So it looks like it's a tough program, but was that accurate? I mean, of course,
I think indeed. Well, I think indeed. Well, we are Dutch, and Dutch means that you try to reach high, but we are also quite democratic. So, for example, we don't have, for example, real elite universities. When you are at a Dutch university, you can go to Groningen or you can go to Amsterdam or to Utrecht. They are all, it has sometimes been compared with, it's a high plain with some peaks, some small peaks. So it's not, we don't have a Harvard and we don't have some provincial college. I mean, I don't want to dismiss provincial colleges. They can be extremely good. But generally, students have quite some flexibility. And of course, they can come to my course on advanced statistical mechanics, which students find really hard. But I also teach courses which are a lot easier. And because we have such we have many electives, and these electives, they are not all that hard. But generally, we try to fix, say, the level of the program. We have a kind of barrier at the beginning, and that's in the math courses and in this G list. Well, but when you have gone through those, then the rest is generally
well, I must say
doable, because then also everything is elective. And in my experience, when students can choose everything, they are usually, what they do, then they are usually better at it.
Well, I mean, you seem to have located 190 folks willing to take the challenge, so that's an impressive number.
No, in fact, when I started as a program director, that was back in 2008, and then there were about 50 students coming into the program, and then it grew, and now this year we have 190. I think a real number, an honest number, would be 170, because some students have been allowed to transfer from the bachelor to the master program, and that was in connection with the COVID situation, so they didn't have to complete their bachelor before entering the master, and I think that has slightly increased the number this year.
Well, it's a large.
Last year we had 160, and the trend is going up.
And I would expect it would continue. I mean, it's a large number, even with the caveats. You know, it's a large program.
Yeah.
So I've got a few questions.
Yeah.
Rod, do you want to just take them from the chat then? Go ahead.
Yeah, that's fine. Okay. So the first, wow, there will be an advanced level next year. Thank you. Oh, that's the QuTech courses I have taken. Okay. Well, thank you, Raya Rika. I can't see the entire name because it's, I think, very long, but it's not really a question. Then we have Sean, the second question, and that's he's completing an applied math physics, coming to masters at Delft in 1 to 2 years time. What is the master's pricing as seen as an international? Yes, sorry, I realized that I told you that the fees were very low, and that is for students from within the European Union. For non-EU students, the tuition is quite high for Dutch. I think it's, well, here you have it. I don't know the practical information, but I think it's something like 18,000 euros per year. But in that case, you can rely, if you are a good student, a really good student, then you can rely on a scholarship. So you can apply for a scholarship from QuTech and or from the TU Delft. So every year we have between 8 and 10 students getting a scholarship. Also, is there any courses on software development like Strata Suzuki, VQE and QFT? Yes, there is. well, there's not too much on QFT, but Roto Suzuki definitely. I mean, I use it a lot, and we also have a course on computational physics, and of course there you learn Roto Suzuki. I am doing VQE with students in a project, so I don't know in which course it exactly would fit at this moment. So I cannot answer whether we have really VQE. The university lectures in the master are all in English, and also the minor program, which I mentioned, that's all taught in English. So the bachelor is in Dutch, but the master programs are all in English. Then there is a question, does QuTech or TU Delft have an internship or summer school program in quantum computing for undergraduate students outside the Netherlands? That's not the case. We don't have summer school programs or quantum computing. So I think it's a very good suggestion, and I can imagine that we look into this for the future. But as an undergraduate student, I think the best option to get to know Delft and learn Delft is to enroll in the minor, which I described, and that is in the autumn semester. But it started a few weeks ago, so it's a little bit too late probably to enroll now. What is the deadline to apply for the 2021 master? The international admissions, they close somewhere in the beginning of April, but again, this is something of which I do not have the practical information at hand, but I gave you some pointers at the end of the presentation, and the presentation, Terrell, that will be made available to the students. So yes. Then you should contact Arno Hackett, and he can definitely answer all those questions. What are the typical level and topics of projects for the master's end project? Well, that's difficult, of course. What is the typical level? It's the level is such that you usually, as a student, you will either collaborate with a staff member or with a PhD student who is doing research or a postdoc, and you are just working along with that guy. Now, the level depends a lot on the quality of the student. So you have very bright students, and they even publish together with other people nature papers based on the master's project. Some people don't get it to a paper, but in principle, I mean, when you ask for the level is determined by you. You have all the opportunity to work with the best people, and if you are strong, you will have a very high level master's end project. The topics, they vary a lot. I mean, I'm not working directly in quantum information. However, I have now a short project with a student who is doing the preparation for a PhD student, where we want to write a code for non-equilibrium Green's functions that could run on a quantum computer. So it's a kind of extension of VQE to Green's function methods. So that's a typical topic. It can also be that you really work in the lab in order to improve the superconducting quantum computing platforms. It can also be that you work on, they are now looking into quantum dots in germanium. And of course, it's always a challenge to connect to all the qubits in the system. And there is, I mean, when you ask for the topics, there are infinitely many possibilities, because QuTech has many people, and also in our department of quantum nanoscience, in which I am a professor, there are quite a few people who have all kinds of topics, and so you should check out the web pages. But that's too many for me to list. What are your thoughts on job prospects after a master in quantum computing? Or would you see a master's as more of a stepping stone to a PhD, which then, that's a very interesting question. In fact, I know that in many physics programs in the US, you go to graduate school, and then first you have 2 years where you do courses, and then if you pass them well enough, you continue with a PhD. In Europe, that's different. In Europe, you go for a master, and then you apply for a job as a PhD. And it's not even badly paid, a job as a PhD in the Netherlands. Now, students from general universities in the Netherlands, such as Leiden and Utrecht, they usually want to go for a PhD, and it's about 50 to 60% of the students in the master program who pursue a PhD. In Delft, that number is lower, and that's not because the students are of lower quality, but it's because we have a different type of students. There are many students who want to go into industry as quickly as possible. And in fact, every industry takes them and really wants them. So our students go, for example, to ASML. And ASML is a big company. They make the machines for baking chips. And so all the chip companies, they have the machines from ASML. There is also Shell who hires our people. And then, strangely enough, it doesn't matter what you do in your master. Every employer in industry wants you if you have done a good degree. And it doesn't matter. I mean, there will be not yet that many employers who can hire you to do quantum research. There will be very few, but nevertheless, they will hire you. And of course, the number of quantum companies, so we have several spin-offs now also from Delft. There is a company, Single Quantum, who makes single photon detectors. There are companies who address the problem of wiring the machines and the fridges such that you can access all the qubits. And students are going there because it's usually a very pleasant environment, because students who set up those companies, they are still, say, semi-students, and so new students really want to go there. So whether the quantum job market will develop as we anticipated now, I don't know whether we anticipate anything, because nobody knows how it will develop. I think the soonest useful applications of quantum technology is probably VQE for chemistry applications, and people expect that to take off in 10 or 20 years. And I think for now it is mainly the companies, say, around building the quantum computing and taking part of the technology and take care of that. I think that's the main job market at this stage. That's my take on this, but I mean, any opinion which deviates from mine has at least the same validity. Next question. I'm taking this year off and want to apply for this master next year. What can I do to increase my chance to be accepted? I guess that is typically something which you should, for which you should contact us directly, because we don't know what your background is. I mean, if we know where you stand at this moment, we can say, okay, you may consider doing this or that. But to answer that question very generally, I think it's too difficult for me, at least. I am more interested in applying for a CSEE master's program. Which of the subject courses remain common in the Applied Physics and Computer Science Electrical Master's program? So if you want to enroll in the applied physics, you really need to have a solid physics background. Okay, that's I can't do anything about that. Now, if you want to enroll in a CS or EE program, there are certainly possibilities, because the courses which I showed and which are taught by QuTech, they can also be taken by computer science and electrical engineering students. And if I go to QuTech, I see students working there from computer science, and especially electrical engineers work together with physicists. And also computer scientists to develop the software. And how exactly which parts of our program, how they fit into those programs, I cannot say that offhand. I would advise you to consult their web pages, where you can see which of the programs are in common. But you can also contact us for this question directly.
Thank you, sir. That was indeed eye-opening, as one chat comment says. I've noticed from afar there's loads of activity going on at TU Delft and QuTech and the whole area there. So it's pretty obvious from your program that a lot of it starts at the university level, in particular the master's. So thanks for that tour. I'm curious about the notion that the future is blue. Is that a subtle comment about IBM?
No, but it is really, you look at the quantum computing, everything looks blue, and indeed, IBM, but of course, I think money-wise, I would guess, I don't know the details, but I guess Microsoft and Intel certainly outweigh IBM in financial contribution.
Well, if we see that in any of their future marketing program, that slogan, we know where it came from, ladies and gentlemen.
I am not funded by those guys.
We all will be someday, perhaps.
Yeah.
They're hiring like crazy. So anyway, more to come out of that. But thank you very much, Jos, if I said that properly. If not, I apologize. But thank you for your time and your obvious energy and enthusiasm for the program. I think you'll stir up a lot of pots and get a lot of people interested in your program. So that number should jump from 190, I would think, over time. So thank you very much.
Thanks a lot.